should be able to see this question here. So there's an implied formula that is not given. The implied formula is that Pert formula.
Mhm.
Okay. So the Pert formula is used for continuous. Okay. And this is that situation here. Now, like your instructor may have said A of t equals like A0, which is the initial amount, e to the RT. Okay. And you're supposed to solve or figure out A0 and then R. Okay.
Mhm.
R is the rate, A0 is the starting amount. So this is A0 and this is R sort of. Okay.
Mhm.
So A0 equals 1,000. So A of t equals 1,000 E. And then notice how it says leaves.
Mhm.
That
So it's
changed the sign
negative,
of, yeah,
basically?
it's negative 0.035 T. All right, is that okay?
Yeah, that's fine.
So now that answers part A. I mean, that's it. So now part 2 or question part, or I don't know, 2, use your model in part 1 to estimate the dose remaining in 4 hours. Okay, so we assume that T is in hours. So you're literally just setting T equal to 4. You're substituting, let me do it this way. A of 4 equals 1,000 E to the minus 0.035 times 4.
Oh, okay.
Oh boy. Okay, did you just start sharing?
No, I just shorted out.
Had something really weird happen. I don't know. Let me get back to where you can see my screen. Apologize for that.
It's fine.
So this is a calculator problem. You're just putting this into the calculator.
Fair enough.
All right. And that's it. So do you want me to get that number for you, or is there
There's no need for that. I just
Okay.
want to know how you do number 3.
Okay. Use your model to estimate when 500 milligrams remain. So this is not even a calculus question. This is going from right here, and it's telling you that A of t is
It's
500.
500.
It's
So you
telling you
just
the
set it equal.
yes. And you solve for t. This is the kind of question you see in college algebra or a pre-calculus class you've had before.
Yeah.
You divide both sides by 1,000. So 1/2 equals e to the minus 0.035 t.
Mhm.
You take the natural log of both sides, and the natural log undoes e.
Mhm.
So you get natural log of 1/2 equals minus 0.035 t. Divide both sides by minus 0.035. And that's your final answer, obviously in the calculator.
Sounds good to me. All right. I'll take a look at another one, see what else can we do. How does D work?
I'll need you to share your screen again to grab D.
All right.
All right, the world population in billions could be estimated by this function. Okay, so that's nice. There's the function. So they want part 1 here. They want you to do P of 5. They want you to put 5 in for T, 6.8 E to the 0.012 times 5, and you get some number. Okay, now that number is in billions. So like, let's just say it's 90. That would be like 90 billion people.
Okay.
Okay, And that's what it means by interpret this value in context. But we can add a little more. So let's actually get the number. I'm not trying to shortcut this, but the number actually does matter this time. So 6.8 times exponential 0.012 times 5. So that ends up being 7.2. So it's 7.2 billion.
Yeah.
So the interpret is in, and you don't say 5 years since January. So it's in 2014. Or you could even say January 1st, 2014. The world population is 7.2 billion.
Mhm.
That's what it means by interpret. You're going to have to write a sentence that, oh, you're not even seeing my screen. You're back to sharing.
Oh, yeah. Let me,
Am I not sharing?
yeah, you're not sharing.
Okay. Why is that happening?
I don't know.
Okay. All right. So if P of 5 means to put that number in for T, you get a number out, and then you got to write this sentence. Okay. So
fair enough.
that sentence comes from the information here. Like it could be a different scenario, but they want to know what this number is and when it occurred. Okay.
Okay.
Okay. Now for the second part, I'm going to write P of T again. It's P of T is 6.8 e to the 0.012 t.
Okay.
And then they want P prime of T first. So they want the derivative. The derivative of E is itself
And
times,
the derivative of that.
which is 0.012. And then they want it at 5s. So this is 6.8 e to 0.012 times 5
Mhm.
times 0.012.
And then how does it work in this context? Would you say so?
Let's get the number first.
Okay.
So let me grab my calculator here. That times 0.012. So this ends up being 0.087.
Okay.
What are the units of this?
Billions of people since January 1st of 2009
So it's population or billions of people
per year.
per year. Okay.
Okay. All right, so that's just it. Could we take a look at number 5 from A?
Sure. You'll have to share your screen again, or you can send me the file.
It's just e to the negative t. I looked at the answer. It says negative e to the negative t, but I don't know how that works. Is it just e to the negative t times basically negative t, or how does it work?
Let me grab it so I can. Let me grab it here. I'm sorry. It's what. There it is. Okay. Let me grab all of them in case you have questions about others. But you said 5, number 5.
Yes, please.
Okay, so let me grab these all in. That way I can go back and look at them later. Okay, I'm going to share my screen. So number 5 is P of T equals e to the minus t. I was trying to really like emphasize this when we're meeting in person is that this right here, you need to keep with it because your next line is the derivative and your instructor wants to see this notation.
Mhm.
So the derivative is itself, but then you have to take the derivative of the inside function.
Mhm.
So what is the inside function? It's minus t. What is the derivative of minus
Minus t
t?
to the negative 2.
It's negative 1 in front, t to the power of 1.
Oh,
d dt of a constant times t or constant times x is always the constant.
oh, all right.
So what is the derivative of the inside function?
The derivative, but is there like one in front of the t, so -1 t would just be -1? Oh,
Yes.
okay. Oh, that's something that I always forget. For some reason, I think that t is like some other variable that I'm forgetting, but it's just acting like an x. That's why I keep forgetting. All right, how does number 14 work? W of t equals 27 e to the 5t minus 1. Do you
Say that,
split it up?
you're talking about set number 7,
For number 14.
number 14.
Mhm.
Okay, yeah, let me get that one again. Sorry, I can see it in another view here. Let me grab it. All right, so number 14 is W of t equals 27e to the 5t minus 1. So now off to the side here, let me just remind you of a few things. D dx of e to the x is itself, okay? And if you have a number in front, like 27 in this case, the derivative is the number times e to the x, okay?
Okay.
But what you have here is slightly different. You have an e to the u.
Mhm.
So that constant comes with it. It's e to the u times u prime.
Oh,
So if we use this last line is the one that applies to your problem. The derivative is you bring the number down,
mhm.
you keep the e, and you multiply by the derivative of the inside function. What is the derivative of the inside function?
Through the inside function would be 5.
Just
Just
5.
5.
Yes. And that's your final answer.
All right.
Okay.
I'm
So
just
let
gonna
me give
write
you one
the,
like, yeah, like get that down. And then I'll give you one like this.
I want to get the derivative rules down on there and then show that example to remember on the test. So W of t W prime of t equals 27 e to the ft minus 1 times 5. Okay. All right. What else do you think is a really important one for me to remember? Like number 6
Well,
or number 8?
let me give you one like this, if that's okay.
That's
Just
fine.
to have you try on your own here, because it's not really let's go. Q of t equals -6 e to the 4 minus t, and I want q prime of t.
All right. So this is so it'll be -6 times e4 minus t, and then multiply it by just since it's -t, is it just -1 there?
Yes, the derivative of the inside function is -1.
So it'll just be +6 e to the 4 minus t, and then it's
Yes.
left alone.
Yes.
Okay.
Okay. So which you're asking about another one here. What
8 and 10. No, 6 and 8. I mean,
6 and 8? Okay. We did look at 8 earlier today. 6, obviously, we can obviously look at both of them again, but 6 is okay. Let me grab 6. 6 is f of x equals 5x cubed plus 2 natural log of x. So it's really just two separate things. You got to be able to take the derivative of this. This is power rule. So what's the derivative of power rule?
power rule the just 15x cubed, x squared.
Good. And then on the right here, as a reminder,
2 over
ddx
x.
is just 2 over x. Nothing more to do there.
Mhm. Oh, I don't do anything more to it.
Nope,
Oh,
nothing to do. 8, you mentioned x squared natural log of x.
so x squared times 1 over x, basically.
It's product rule.
Oh,
So you have to,
then 2x times 2 over x.
you've got to break it up into u and v.
Oh, this is a product rule. That was something that I was forgetting. So I'll write that down. So x squared ln of x, divide it And I'll do UV prime plus U prime V product rho PR. Okay.
So part of what you were telling me earlier was correct. It's just that you were potentially going to miss some of the important stuff here.
Mhm. I was about to miss all of the important stuff.
Yes.
So it turns into x plus 2x ln x. Oh, all right. I understand that now. I was just really sleepy when we were doing that.
Understood.
So I
Yeah.
so I wasn't really paying attention. I could see all of this. I think we did, yeah, we did two. Two is pretty straightforward. That turns into negative, I think it was negative 90 to the 2x minus 9 to the 14th. And you get
Yeah.
the 2 out of the derivative inside, which is
Yes.
2x.
Yes.
Okay. What about number 11 and 12?
Okay, so let's look at number 11. Y equals x squared plus 13, but it's the square root here.
Mhm.
And there's a really important rewrite step here. The rewrite step is to raise this to the power of 1/2. So maybe on your note sheet, if you feel like this is worthy, is this reminder over here on the right. Okay.
Okay.
So your derivative is you start with the power rule. The exponent is the outermost function.
Oh, the outermost function, would that be, okay, so 1/2 in the front and then
Yes,
to the negative 1/2, and then the derivative of the inside, which would be just 2x
that's right.
on the outside? Okay. I'll write this one down because I think that this might be something that I would probably end up missing because I'm just not really looking very thoroughly at it. So what? This would be y equals x squared plus 13, 1/2. Y prime equals 1/2 x squared plus 13, negative 1/2 plus 2x. Okay. What else was I looking at? I think it was either 11 or 12. I think 12 looks a little more challenging. Yeah, we just did 11. Oh, never mind. I wasn't looking.
I can show number 12 here on my screen. It's written as y equals the cube root of 11 minus 2x squared. So the rewrite here is when you have the nth root of x to the m, this equals x to the m divided by n. You have to know the positions for these things to be able to do it. So if you follow that, the exponent here is 2/3. And this is your rewrite step. You're rewriting it so that you can actually evaluate the derivative. Now it's just like the last one, it's power rule. You just bring the exponent down, you subtract 1, and then you multiply by the derivative of the inside function.
All right, it's straightforward enough. All right, and then the prime inside -2. Okay. I'll write this one down too. Because of the rewrite. Cubed 11 minus 2x, and square that up, and then y equals 11 minus 2x to the 2/3. Y prime equals what's 4?
I'm sorry,
How would we do number 4?
number 4. Let me get it down here. So a of t equals 3 to the t plus e to the t. So the first one is a number to a variable. Okay.
Mhm.
The second one is also a number to a variable.
Number two
Okay.
variable, that one's,
So in both cases, your d dx, your rule is you keep it natural log of the base. So it's what you started with times the natural log of the base, 3 in the first one, natural log of e in the second. The natural log of e is really 1. So oftentimes you see books capture that where the derivative of e to the x is e to the x.
oh. Okay, so 3. Okay, that makes sense. For number, I think we just did number 5. I just want to make sure that I got that right. So it's basically just e to the negative t. That's that one's just a number to a variable basically. And then you
Or number
multiply.
5.
Yeah, for number
Yeah.
5, the e to the negative t. And then you multiply it by the derivative inside, which is a -1.
Yes.
Okay. Be sure that I got that down. What about is number 14 a product rule, or what do you do with it?
No, we did 14 already tonight, Jack.
Oh, can you go back up real quick? I want to review it. I keep forgetting it. All right, here we go. Oh, okay. Just making sure that I'm not missing anything out. How does number 13 work?
All right, so let me get 13 down. All right, so f of x equals the natural log of the cube root of x. Okay. So the rewrite here, it comes from what we did earlier. The part inside here becomes x to the 1/3 power. Okay. So the derivative is f prime here. It is 1 over x to the 1/3. Okay. 1 over
Okay.
whatever's inside. But then you multiply by the derivative of the inside function. So the derivative of the inside function is, we're going to put that here. It's 1/3 x to the -2/3 power.
Oh.
So
Okay.
the simplification here is you get 1/3 x to the -2/3 over x to the 1/3. And if you recall, when you have the bases are the same, you're dividing, you subtract the exponents. So this becomes x to the -2/3 minus 1/3, which becomes x to the -3/3, or x to the -1, which becomes 1/3 times 1 over x.
Oh. Okay. So that's just all right.
All right, so we're at a break point here, Jack. If you would like, we can stop here. I can credit you for a half hour at another time. If you want to keep going, that's great. I'm happy to keep helping. Please let me know what you want to do here.
I think that I've done enough for tonight. Thank you so
Great.
much for your help. I appreciate
Absolutely.
it.
I'll send you the notes here shortly. And when you're ready to use that half hour, just let me know and send me a text.
I'll let you know. Thank you so much.
Have a great night. Bye now.
You too. Bye-bye.